Hello, and welcome to Section 2, Implementing Observables to Reduce Code Complexities. In this section, we will find out more about observables and the main ways how to create them for the different use cases. You will learn what cold and hot observables and subjects are for. Then, we take a look at some interesting observables usage in application state management system. In the last video of the section, with a simple example, I will show you that updating web components view on sporadic data change becomes easy when we use RxJS. So, what are observables and how to create them? Let's take a look at the definition that ReactiveX gives us. Observable is a stream data structure that models TC39 observable spec proposal. Observables are lazy push collections of multiple future values or events. Keywords here are stream, push collections, and future values. By the way, if you didn't know that, TC39 is the committee that evolves JavaScript. Its members are big companies. It includes all major browser vendors. Observable data type is one of the drafts that are being reviewed by TC39 for now. Maybe sometime it will become a part of new JavaScript version. But at the moment, JavaScript doesn't have observables included. So we use RxJS to get its functionality. Now let's take a closer look at the definitions, so you can understand more about what observables really are. Observables are lazy push collections of multiple values. We already know that unlike promise, observable can produce many values over time. But what does it mean, push collections? When observer wants to subscribe to producer updates, it provides callback function. This callback will be called each time producer sends a new data. After subscription, observer doesn't really know when producer or observable will send the data. It means producer will control when your callback function will be run. It is called push system. You are pushed with the data you didn't specially request for. Someone call it Hollywood principle. Don't call us, we'll call you. If it is clear about push systems, then a few words about why observables are collections of future values. To better understand this, let's take a look at array. Array prototype in JavaScript has map method. It calls its argument function for each item of the array. But we can say that it receives each item instantly, in a milliseconds, because these values are in array already. If we talk about observable collection, then its values also can be handled, but not at once. They come one by one in different periods of time. And each time next value comes, handler is called. So you can think about observable collections like future values array. The core observable concepts that ReactiveX specifies are creating observables, subscribing to observables, executing the observables, and disposing or canceling observables. We will return to creating observables in a second. But first, let's cover subscribing, executing, and disposing. You can subscribe observable with, guess what? Yes, subscribe method. And as a params, you should provide onNext, onError, and onComplete handlers. Actually, you may omit any of them, if, for example, you want to handle only onNext data values. Subscribe method returns subscription object that will give you disposing control over observable events listening. Observables use lazy evaluation. It means it will not run until you subscribe. It makes sense, since if no one needs your data, why to produce them? We will talk more about this in the next video about cold and hot observables. Unlike promise, you can dispose or stop listening for observable data anytime. Just call unsubscribe method of subscription object to prevent your handlers to be run. To wrap up previous slide, observables use lazy evaluation. They don't run until they are subscribed. If sequence throws error, it completes and produces no more values. OnComplete handler is called when sequence completes or when it throws error. You use subscribe method to start listening for observable events, providing onNext, onError, and onComplete handlers, or just some of them. Subscribe method returns subscription object. To stop receiving events from observable, just call unsubscribe method of that object. Now about creating observables. There are many Fabric methods and functions to create observables. Here are some of them that I find the mostly used. And we start with Observable.create static method. To get more up-to-date information about last RxJS version functions and operators, just proceed with the link at the bottom. Observable class has a static method, Observable.create. Sometimes we need more complicated logic while creating observables or retrying them on error. So if we want observable to depend on some external variables that can vary during some time between subscriptions, then we need defer. In its callback function, we get observer object that has next, error, and complete methods. So respective handlers of subscribers will be affected when we call any of them. I just call next method here to produce values for subscribers. This method of observable creation, sometimes called manual. Usually in our daily work, we will use creation functions. Let's try it in a CodePen. Here we emit values each second with set interval. You can see them in a console. To emit values, we call observer.next method. To error observable sequence, we can call observer.error method. And to complete the sequence, we just have to call observer.complete method. And now the set of observables are quite specific, and we will learn them one by one. Defer creates an observable that, on subscribe, calls an observable factory to make a fresh observable for each new observer. Why do we need defer? Sometimes we need more complicated logic while creating observables, or retrying them on error. So if we want observable to depend on some external variables that can vary during some time between subscriptions, then we need defer. In this example, you can see that each time I subscribe to source sequence, I get different starting value. Of course, this example is very simple, but it explains very well how defer works. In my work practice, I use defer in observable with retry logic, when you should change initial observable params on retry attempt. We will talk more about it in practicing the retry logic section. Let's check this example in our CodePen playground. Off function creates observable, takes argument value and emits this value. We will talk about off a few slides later. As you can see, factory function is called each time I subscribe to original source observable. By the way, it is very convenient to name observable variable with a $sign at the end, so you can recognize any time that it is a stream. Let's now talk about empty and throwError. Empty creates an observable that emits no items to the observer and immediately emits a complete notification. throwError creates an observable that sends no items to the observer and immediately emits an error notification. So, error handler of the subscribers will run. Usually we use them in observable sequences to construct conditional logic. It means that sometimes we need sequence to throw in some condition or return empty sequence in another. Just a simple example for now. Switch map re-subscribe observer to the sequence that callback function will return. And depending on conditions, we can return different sequences or errored sequence. We will talk more about pipe, switch map in observable combining and flattening videos. Here, if we meet condition 1, then result observable throws, and error handler will run. If condition 2 is true, then we get sequence that completes without any values, so complete handler will be invoked. If no condition is met, we return observable that will emit Ajax call results, so our onNext handler will run to process data. Next set of observable creating functions, mostly used for learning purposes. Interval creates an observable that emits a sequence of integers spaced by a particular time interval. Range creates an observable that emits a range of sequential integers. Timer creates an observable that starts emitting after initial delay and emits ever-increasing number after each period of time. Let's take a look how they work in Rx Visualizer. As you can see, interval generates values each second, as we set it. Let's try range. Range generated 4 values, but almost at the same time. Timer starts generating values after initial delay. Here initial delay equals 0. The next set of observable creating functions are met more often in my practice. Off converts the arguments to the observable sequence. Each argument becomes a next notification. It doesn't do any iteration or flattening of its params. Just emit them as they are. So if you put array, you will get array as emitted data value. From converts some other object or data structure into observable. Unlike off, it accepts only one param of observable input type. It means that param can be array, promise, or observable. From function iterates array and emit each array value. It also can resolve promise and emit resolved value. fromEvent is usually used to wrap user input events in a stream. We already saw an example in a section 1 video, where all input element value changes was converted to observable sequence. As you can see, off function just emit params. Let's try from function with different types of arguments. As you can see, it iterates over arrays, resolves promises, and remit observable argument values. In fromEvent example, we used map operator to extract input value from event object, and the bounce time operator to prevent emitting values if person is still typing. We will talk more about them in the next section. Here are a few more examples about off. So, to wrap up, off function just emit arguments one by one as they are, without any transformation. From function iterates arrays, resolves promise, and emits promise values and remit observable values. fromEvent, in this example, we convert input key up events to the observable sequence of input values. Ajax function wrap Ajax request and creates an observable from it. You may ask why, since we just expect single value from it. Not always. Sometimes, depending on response data, we need to do some more complicated things, like making another request using previous response data, or retry the request on error. So, wrapping Ajax request in observable allows us to use all power of RxJS for such non-straightforward request logic. We will talk more about it in a practicing the retry logic section. Just for your convenience, I provided import links here. If your web project uses ECMAScript 6, then you can just install RxJS with Node Package Manager and then import creating functions from respective modules. For our CodePen examples, and if you don't use Bundler in your project, honestly, it is quite rare for enterprise development for now, you can anyway import respective Fabric functions to create observables. Just add script tag to the head section of your HTML page, and then follow the pattern I provided on the slide to reach these functions. To wrap up this video, Observable is a stream data structure that can produce values. Observables are created using static function Observable.create or creation functions like of, from, defer, etc. You can call subscribe method to start listening for observable events, providing onNext, onError, and onComplete handlers, or just some of them. Subscribe method returns subscription object. To stop receiving events from observable, just call unsubscribe method of that object. As you may notice, many observable creation functions has scheduler param. It affects the timings of events emitting, and we will have a special lesson about schedulers.